In this video, we will compute the Laplace transform of the shifted function u sub c of t times f of t minus c. Recall that this looks like 0 for t less than c and f of t minus c for t bigger than or equal to c, because u sub c of t is 0 for t less than c and 1 for t bigger than or equal to c. To start computing the Laplace transform, we'll go back to our definition, which is that the Laplace transform of a function is the integral from 0 to infinity of e to the negative st times that function dt, where the function here is u sub c of t times f of t minus c. Now, since u sub c behaves differently before and after c, we'll split our integral up and do the integral from 0 to c plus the integral from c to infinity of e to the negative st times u sub c of t times f of t minus c dt. In the first integral from 0 to c, u sub c is 0, and in the second integral, u sub c of t is 1. Focusing on the first integral, since u sub c of t is 0, that entire integral will be 0. And we're left with just the integral from c to infinity of e to the negative st times f of t minus c dt. To proceed with this integral, we'll make a substitution v equals t minus c. Doing this, we get that dv is dt, and the lower bound will change from t equals c to v, which is 0, since v is defined by t minus c. So when t starts at c, v starts at c minus c, which is 0. Our upper bound will be unchanged because as t goes off to infinity, v, which is t minus c, will also go off to infinity. Using this substitution, we can rewrite the integral as the integral from 0 to infinity of e to the negative s times v plus c, when we replace t, times f of v dv. Now e to the negative s times v plus c can be split up as e to the negative sv times e to the negative sc. Now, since e to the negative sc is constant with respect to v, we can bring it outside of our integral and rewrite the integral of our function as e to the negative sc times the integral from 0 to infinity of e to the negative sv times f of v dv. Even though we've written this integral in terms of v, the variable we use doesn't matter. Once we integrate with respect to v, the integral from 0 to infinity of e to the negative sv times f of v dv is simply the Laplace transform. So we can conclude that the Laplace transform of u sub c of t times f of t minus c is equal to e to the negative sc times the Laplace transform of the unshifted version of f. Since we need to be able to take inverse Laplace transforms in order to solve differential equations using Laplace transforms, it's also worth noting that we can reinterpret this in terms of the inverse Laplace transform, which says the inverse Laplace transform of e to the negative sc times the Laplace transform of f of t is equal to u sub c of t times f of t minus c. So whenever we have a factor of e to the negative sc for some value c in our Laplace transform, we will need to use one of these shifted functions to get the inverse Laplace transform. We'll look at an example of this in one of the upcoming videos.